So my dear students, that is the ninth experiment of attenuation measurement. We have to learn the attenuation measurement techniques of microwave components. Although attenuation in general means reduction of decrease of something, it specifically refers to the ratio between the input to the output power in microwave, 10 into log P1 by P2. P1 is the input power, P2 is the output power, and we have to find out the attenuation measurement by this equation, the power ratio method, and that is the RF substitution method. There are two methods of finding out this. So that is the basic experimental setup for the preliminary adjustment. So the power supply connected to the Gunn oscillator, square wave generator, then PIN diode modulator, and it have to be go through to the variable attenuator, crystal detector, and that has been connected to the SWR indicator. Turn the power supply on, apply 1000 pps modulation signal to the PIN diode, adjust either pulse repetition rate or the frequency on the SWR indicator for the maximum deflection on the SWR indicator. Measurement using the power ratio method, set the variable attenuator to 20 decibel, set the SWR indicator gain to the either 30 decibel or 40 decibel range, and adjust the indicator for 0 decibel. Using a directional coupler, add a matched termination to the setup as shown in figure 9.2. Obtain the reading of the SWR indicator, calculate the actual coupling of the directional coupler. Then the procedure 2, 3 and 4 should have to be repeated for to set the attenuator 15 and 10 decibel repeatedly. Okay, that is the variable attenuator. Just repeat the same procedure through fixed attenuator. And there is an unknown section that is used by the directional coupler. Okay, so measurement using RF substitution method. Connect the crystal detector to the PIN dot modulator. Set the variable attenuator to 20 decibel. Adjust the SWR indicator's range switch and gain control so that the indicator can indicate 0 decibel. Insert the directional coupler and connect the crystal detector to the auxiliary arm of the directional coupler without altering the SWR indicator setting. So that is the device under test. That means the directional coupler that has been shown there, and slotted shorted plate, and there is a fixed attenuator and a variable attenuator. Both attenuators are there to measure the low value of attenuation, and there is a slotted line to find out that the SWR indicator to find out the SWR out of it. Set the variable attenuator 20 dB and measure the input SWR of the device under test. Directional coupler in this case, device under test means that is unknown to us, and if we find out the certain characteristics of directional coupler, so that is a directional coupler. Okay, redetermine the attenuation using the following expression. That is the expression to find out that, and that's probably the end of the ninth experiment. The last but not the least, the experiment number 10, the study of a waveguide hybrid T. Understand the basic principle of hybrid T. Learn measurement methods of hybrid T characteristics. The theory is that a hybrid T or a magic T, it's just like a figure like that, and that is the balanced bridge circuit and quite equal to the hybrid T or magic T. And electric field input applied at port 1, that would not go through to that, but the electric field with input applied at port 4, you will find out that there is a change. Okay, there is a symmetrical change. There is no change in that particular point. There is no change and no attenuation, as you can say, there is no propagation in that part. But if you just similarly just input the value of through to the fourth port or H port, you will find out that there are two different direction electric field that go through to that part. Okay, so that is the magic of the magic T waveguide. So as you can see, that is a side view of the junction hybrid T10 mode, and that is the experimental procedure Same as all of the previous procedures, the GAN oscillator to the power supply, a square wave generator to the PI diode modulator, that means simple modulation circuit through the microwave measurement devices. Then go through to the fixed attenuator, variable attenuator, and crystal detector to find out the value of the microwave power, and go through to the SWR indicator. So set the equipment as shown in figure 10.4. Adjust the SWR indicator gain obtaining any convenient deflection. Apply 9 volt to the GAN oscillator. Apply modulation voltage to the PIN diode modulator. Adjust the offset voltage and the pulse frequency to the square wave generator to obtain maximum deflection on the SWR indicator. There is a measurement of decoupling between H arm and E arm. Okay, now that is the same section in the previous part, but just connect a hybrid T between these two. The second port connected to the match termination, fourth port or H port should have to be connected to the crystal detector, and the E port should have to be connected to the waveguide to coaxial adapter position. Then thermocouple mount and power meter to find out the power. Okay. Now, setup diagram for measurement of decoupling between H arm and E arm. Set the equipment as shown. Set the attenuator to 20 dB A1. Select a range on the SW indicator which gives a reasonable deflection on the indicator. Adjust the gain control to a reference reading on the dB scale of the indicator. Remove the detector and connect the variable attenuator to arm 1. Connect the matched terminations and power meters to arm 2 and arm 3, and connect the detector to arm 4 that has been selected there, and increase the sensitivity to the SWR indicator to 10 decibel increment until the same preference in 3 is obtained. Okay, record the results to 10.1, and that's gonna be the end of that. For finding out how the variation, we have to find out the meter again, and A1 minus A2 plus nx10 is the decoupling factor. N10, that not nx, that's n into 10. N means steps. And measurement of insertion loss of hybrid T. Same connection, set at 20 dB. The attenuator is SWR indicator are there. So just find out, and that is gonna be finding out that, and then you should find out the return loss, measurement of the H arm. To find out return loss, you have to use the directional coupler and a shorting plate in the main arm of the directional coupler, and the another arm of the directional coupler, that is the bended arm, or you can say the perpendicular arm, should be connected to the GAN oscillator and power supply. So quite what you can say, altering the connection through that. Turn on the GAN oscillator, do not exceed 9 volt. Adjust the square wave output of the maximum modulation. That means the modulator, first time the modulator and the power supply are on the different side of the directional coupler. Okay, that means the auxiliary arm. Okay, and set the variable attenuator to 20 decibel. Set up the reference point as SWR indicator. Remove the shorting plate and connect arm 1 directional coupler as shown in the previous, and connect a matched termination to arm 3. Leave arm 4 open and increase gain to the SWR indicator, and 10 decibel increment, decrease attenuation, then repeat 5 and 6. You will get your value right there. That is the return loss measurement setup. As you can see, there is a return loss measurement setup using the hybrid T. That is the hybrid T. In previous section there is no hybrid T. There was a same connection, but there was, you can see there is a reflection shorting plate, and here is no shorting plate. Just use hybrid T with a 4 port open, 4th port open, and same as the previous, waveguide to coaxial the 2nd port, thermocouple mount power meter to find the power out of that. And that's all for now, and the end of the lecture series of the laboratory experiments of microwave engineering lab. Thank you very much for being with me in these sections, and I hope your well-being in life.